Hi, my name is Darko Subotin and I'll be showing you in this tutorial how to set up physical lights using the blueprints that I have made. This is not a tutorial for complete lighting overview of Unreal Engine's light system, but rather just how to use my tools to make physical lighting in Unreal Engine work. So I'll be going in this tutorial first over the project structure and then over the blueprints. And then I will be showing you the workflow that I use for setting up physical lights on a simple scene, and then we'll move on to some interesting scenes from Epic's free content it provides. So let's get started. So here I have the project open. I have made a simple and clean project inside of which you will find the Darko's Physical Lights folder. So you open that, and inside you will find the Blueprints folder where all the tools are. So I have a simple character, pawn, Lightmeter, lights. So this has exposed parameters and some various other parameters for controlling light intensities. I have a Reinhardt folder, which is, so I tried to implement my own custom tone mapper by replacing the Unreal Engine's tone mapper. This is an experimental feature, so I don't recommend you use it for your projects, but I included it if you want to see how I set it up. We have our Sky folder, inside of which you will find these blueprints that you will be using the most. Inside the Maps folder I have the Light Demo map, so that's this map where you can try out various lighting scenes. I have my materials, meshes, some starter content from Epic's starter content library, and some HDR textures from HDR Haven. So now let's go over the tools. So I'll start with the Lightmeter. So inside the Lightmeter folder, we have our Lightmeter blueprint. If we drag it out into the scene, this is what we get. Now, I'll just set this up so it's not white. So you can see here what the Lightmeter is seeing. You can also enter the Lightmeter by piloting it and actually point the Lightmeter in a direction that you want. So this is actually showing us the linear value of the center pixel of what the Lightmeter is seeing. So this is the same as the pixel inspector. So this final color luminance, we'll be talking about this later on. This is the exposure of the Lightmeter. So basically how it works is it needs to find the correct exposure to give us the correct linear values. And these tools, this button and this EV increment is for finding the correct exposure. So it's like a half automated process. And this EV in range shows us if this is green, then that means that the Lightmeter's EV is within range. This button then calculates the average luminance values of what the Lightmeter is seeing. So it gives us the average linear value, the average final color value, the average luminance lux, and the average candelas per meter square. Also, it gives us the average EV value of the scene. So if you want to find your scene's EV, you can actually increase the camera's field of view and then compass your whole scene, and then calculate the average to find what the EV should be for your scene. Now, of course, that would be a starting point because sometimes it gives you a little too bright or too dark values. So that would be the Lightmeter. So I'll be going over one light, and because the parameters for the rest of the light blueprints are pretty much the same. So we have our rectangular light. So here it shows, in the details panel, it shows the candelas, it shows lumens. This is the width and height of the light. This is the barn door angle, barn door length, and you can set in what units you want to work in. So you have candelas, lumens, and I added luminance values, which is candelas per meter square. Also, it shows you lumens per meter square. And you have your temperature set up for your lights. And we have inside our sky folder our outdoor lighting captured BP and our outdoor lighting captured sky blueprint. So basically the difference between these two is that this one has a sky dome where you can load in your HDR, while this one does not have a sky dome, so you can use it for your custom skies if you have an auto-generated sky or some procedurally made sky. The important thing is that your sky actually can emit high enough values for physically based lighting. So I have this blueprint in my scene. So this show text has some useful information about various lumen values of light bulbs. This has some various luminance values of the sky, and this shows us some common sun illuminance values. You can turn this off. So this parameter actually changes the material instance, this sky material instance, and its emissive parameter, so it sets it to the correct value so that we have our desired candelas per meter square value on the sky. This is where you load your sky texture EXR. You can rotate the sky independent of the sun. You have the base sky luminance. We'll be going over this later on. This shows the luminance in lux, and this is an update button which you can find in every section, because sometimes if you change some parameters the blueprint won't update. With this you can recapture the sky, and this is where you set your desired sky candelas per meter square. So this is for the sun and setting up the directional light. So you actually have to have a directional light in your scene for this to work, and then you have to pick it. So you can set its color, its intensity, temperature, and elevation and latitude. This is for easier control of where your sun will be. So this global spec is set up because before I realized some things about Unreal Engine and how it works, I actually made a specular control system, because I realized that as I increase the skylight, my specularity also increases, and at very high values the specularity blows out and becomes white. So I implemented a system where in each material I would have a material function, and these parameters actually control some parameters inside that material function. So if you want to implement that, you can use this as a global control for your specularity. I realized that it might be useful, so I didn't throw it out, but I included a checkbox so you can completely disable or completely enable it. So if you want to use these global specular controls, you have inside the material functions, you have these two functions. So the difference is that this actually attaches to a material attributes, and this is actually a regular function. So you just have to add this at the end of your material graph and everything will work. So since I realized that the specularity relates to light intensity, I actually created a curve that describes this relationship, and this is where you can change some parameters of that curve or implement your own custom specular curve, which is found in Sky Custom Spec Curve. So if you open this, you can see how the specularity relates to light intensity. So these are some very important parameters that we'll be going over when we are talking about the workflow. So I expose some camera post-process settings, exposure compensation, minimum maximum EV, the eye adaptation speed, bloom intensity, and color temperature for the camera. And this is the tone mapper section, where we have our control for the ACES tone mapper. And we also have a gamma correction. So this actually gamma corrects the image inside the tone mapper, and it's not the same as gamma correcting it with a post-process volume. This is the actual tone mapper gamma, and this is the checkbox for using my Reinhardt tone mapper. So if we check this on, you can see this is now my Reinhardt tone mapper. It basically has more saturated colors, especially more saturated reds, and you have some controls for the exposure of the Reinhardt tone mapper and for color temperature of the Reinhardt. Now, this doesn't exactly work well yet, so that's why I don't recommend using it. Now, if you're using the Reinhardt tone mapper, you should know that you need to use a custom. So inside your pawn character, you actually have to implement this Reinhardt eye adaptation, because otherwise you won't have an eye adaptation inside your scene. Okay, so now I've gone over the tools. So we can go on to how the workflow goes. So I have deleted every light in the scene, so that's why it's completely black. If you go into unlit mode, we can see that we're in the demo mode scene. Now, before we start working, we have to make sure of a couple of things. First, you have to set in your project settings. We type exposure. This extends default luminance range in auto exposure settings. This is very important, otherwise the tools will not be working correctly and you can't work with physically based lights in the scene. So this has to be on in every project that you use these tools and where you want to be working with physically based lighting. So in order to start working, we need to bring in our sky blueprint. Now before we do that, let's just make sure that in the world settings you also have number of indirect lighting bounces set to a high number and number of sky lighting bounces set also to higher than 1. I'm using the Luoshang's GPU light mass, so that's why I've ignored all these other settings. I won't be going over the light mass settings, there are plenty of tutorials for that. So for the GPU light mass, these two parameters are the most important, so that's why I've set them up like this. Also, if you're working with the GPU light mass, I have found that you need to set some parameters inside the base light mass ini. So here you have to increase the firefly clamping threshold to a high number. By default it's at 1000, which means that the skylight will not be able to emit higher values than 1000. So in order to be able to emit higher values, you have to set this to a high number. I've set it to 100,000. So firefly clamping threshold. Also, before actually setting up your lights, make sure that you either have your exponential height fog deleted from the scene or that you have it disabled, because it can mess up the calculations of the light meter. So the first thing to do is to bring in our blueprint. So this is how it looks like when we bring it in. So in the details panel, I will be just turning off the show text. So I'll set up some simple overcast lighting because that shows us some problems that I've encountered while trying to figure out physically based lighting. So when you brought in your blueprint, then you go into your textures and you set up one of your HDR textures. So I'll be using this overcast. So I'll bring it here. Now, this is what we get. Now, before we start changing any parameters, we have to actually measure the luminance of this sky. So what's important is that these settings, sky candelas per meter square and base sky luminance, are 1 when you first import your HDR texture. Then we take our light meter and point it at this part of the sky that's not neither too bright nor too dark. In this case, the sky is pretty much illuminated evenly, so we can just point it somewhere upwards. And we find the correct EV for our spotlight. For our light meter. So in order to do that, we have to adjust this EV increment and click a couple of times on this button, which will then try to find the middle value of the center pixel of what the light meter is seeing. So what we aim at is that this final color luminance should be around 0.16. So I will start with 1, click it a couple of times, and if it starts flipping from one side to the other, then I just lower the number to 0.1, and it's 0.16. This turned green, so it means that the EV is in range. Then we can calculate the average values. So this takes the average of what the light meter is seeing, and what we actually need to copy is this value, average linear value. We copy that, and we put it into our base sky luminance candela per meter square. So we have to set this up for every HDR that we are using. But if we set it up once for one HDR, then we don't have to set it up for anymore, so we don't have to change this value. We can update. And now we can actually enter our desired sky candelas per meter square. You can check what that is for a overcast scene. It's about 1000 candelas per meter square. So we put in 1000 here and update. So this turns white, and that's okay because we have not set up our exposure yet. Since we won't be using right now a sun, this is pretty much all we need to do. So right now we can calculate the lighting and then see how the scene looks like. So as you can see, I'm using the GPU light mass. Now, depending on the scene, if you have a very heavy scene, then you have to have a very good graphics card for this to work. So now this is our scene. It's completely white, which is expected. Now, if we want to find what the starting EV should be, we can go back to our light meter and find the exposure again. Since we changed our sky, light meter's exposure values have changed. So we are aiming again at 0.16 or until this turns green. So we have found it. We click calculate average, and it says to us that the average scene EV is 13. Okay, so I plug in 13 into my camera. So this is what we get. It's pretty dark. Now, the other important things we have to do. We have to actually use a gamma correction, because for some reason the default gamma so within the tone mapper is 0. So what this means is Unreal Engine is calculating lighting in a linear color space, in linear values, but by default it does not apply a gamma correction to the calculations after it calculated the tone mapper. Now, if we just put a gamma correction in a post-process material, that will gamma correct our low dynamic range image, which is not what we want. I can show you what will happen if we take a post-process volume, set it to unbound, and in the global section of color grading, we set a gamma. So let's say 2.2. This is what we get, and it's pretty washed out. So what this does is actually gamma corrects the final image, and that's incorrect. What we need is a gamma correction inside the tone mapper. So in order to do that, I have included that option here. So right now I've set it tone mapper to 0, so nothing changes. But if we put it to 3, now our scene becomes brighter, and our lighting will actually behave differently. I will be including a very useful article about gamma, this article, which actually explains what's happening and why gamma correction is very important in 3D rendering. So I highly recommend that you read this article to understand why I've implemented the gamma correction in the tone mapper. Now the logical value for this tone mapper would be 2.2, but because that's the sRGB gamma correction, but it's still kind of dark for me, so I found that the value 3 actually brings me much better results. And also, since I've worked on the Reinhardt tone mapper, I've implemented a gamma 2.2 correction after the Reinhardt calculations, and I found that a gamma of 3 here actually represents much closer to the gamma 2.2 that I've included in Reinhardt, so that's why I'm using a 3 as a gamma for the tone mapper. Now, as you can see, our scene is pretty washed out still, and that's because of how Unreal Engine is combining reflections with light mass. And you can find out more information about that in the reflection environment, light map, mixing, and existing content. So here they describe what they actually do with the specularity and how they mix reflections with lighting. So I realized that they were actually adding reflections as the light mass increases, and in order to fix that, we have to put this value to somewhere 1. So if we do that, the light map mixing will change, but our reflections and specularity and everything will still stay. So you can find out more information about this. I've included tooltips for everything, so you can actually read them and better understand what's happening with every parameter. I also recommend this. You can find more about console variables and commands here, because these parameters are actually console variables as well as the gamma correction. So now that we have set it up, we just have to adjust our EV to something a little better, and we have our lighting set up. Now, of course, you have to have proper reflection probes set up so that the reflections are working correctly. As you can see, it's not too dark inside either, even if we just have a skylight. If we turn off gamma correction in the tone mapper, we get this result, which is too dark. So your first instinct would be to actually increase the lights or light intensity, which would be wrong. Okay, so that's basically the workflow. and what you have to look out for. And now I'll be moving on to some more interesting scenes and set up some lighting scenarios. Okay, so I have opened the realistic rendering scene here to showcase how the physically based lighting can be set up in some interior scenes. So, as you can see, there are no lights in the scene. I've deleted everything. I've made sure that in the project settings, the extend default luminance is on. So, in order to create our scene, I will be showing you how to set up a daylight scene and a nightlight scene. So I have migrated my project from the Darko Physical Lights from the Darko Physical Lights project. So we have our blueprints, so we will start with the outdoor sky. So I'll put in my sky blueprint. I'll move it a little bit outside here. And we can go into the lit mode so we actually have some light visible. Now I will load in some textures, some HDR textures. So I will load in a, let's say, this one. So this is like a midday EXR. So this is what we have. Now we can rotate our sky a bit so that our sun is facing our window. Okay. And now we can add, so before we do anything else, we will measure our sky with the light meter. So I'll bring in my light meter. I'll bring it up somewhere here so that the scene doesn't occlude the light meter's view. Actually, I already have a light meter. One thing, you cannot have two light meters in the scene, then the light meters won't work. So I will pilot the light meter and I will find the part of the sky that's not too bright. So I can't be close to the sun. I won't be close to the horizon, but some part that's not too bright nor too dark. So somewhere here. I don't recommend including clouds in your view of the light meter because clouds have a vastly different candela per meter square value. So I will find the middle value. .16. Calculate the average linear value, copy that, and plug it into my base sky luminance, and update. Okay, we capture sky. Alright, so the next thing we can do, so we can set up our sky luminance immediately. So if we look at these parameters, these information, we can see that an average cloudy sky is around 2000 and the clear sky is around 7000. So this isn't too cloudy nor is it too clear. So I will use something in between. So around, I don't know, 5 to 6000 will be fine. I'll use 6000. Update. And now we can just set up some exposure. I know that 16 works well for daytime scenes, so just that we can see what we are doing. I will bring in a directional light, and I will immediately set up the temperature settings on the light so that when we pick it with our blueprint, the temperature settings update. And I will set my cascaded shadows to 3000. So I'm currently always using stationary lights, but this should work with movable or with static lights as well. Now I will pick my sun. And now I have included a sun on the sky, so you can see where the actual sun is when you rotate it. So I can set the elevation and I can set the latitude. So I will put my sun where my sun in the HDR is, like so. And I will put my sun's lux value to something that's common for this type of sky. So let's see, common sun illuminance values, direct daytime sunlight between 32,000 and 130,000. I will put 100,000 into the sun intensity value. Okay, now when I'm inside, since I can't really see from the inside where the sun is, I can fake it a bit and lower the sun so that more light comes in to our scene. Like so. I put my sun temperature to around 5,800 kelvins. Update. And that's pretty much it. We now build the lighting, and I will come back when it's built. Okay, so my lighting have been built, and this is how it looks like immediately after the build has finished. So as you can see, it's pretty dark inside. That's due to a couple of reasons. One of it is the gamma, so we will turn on the gamma. As you can see, everything turns much brighter, and you can actually see inside the room. And also, you know, 16 is pretty high number for an interior, so I will lower this to like 12 or maybe even 13. I'll add some bloom, and here we go. So we have our interior scene, and as you can see, when we look out the window, it's not completely blown out as you would expect in real life. So of course it's really high difference between the interior and exterior values. So but still it's not completely white as we had problems before with Unreal Engine. Also, I make sure that set to this to 1 so that my specularity is not overblown. And this is our final lighting setup. So as you can see, it's nicely lit up, even though we are just using one skylight and the sun as our main source. And so this requires realistic EV numbers to be set up so that it works correctly. So we can see without the gamma correction, it's pretty dark, and with the gamma correction, it's good. Now, we can, on top of this, always do some post-processing, some color correction, some contrast, because that's basically how you do it when you render with an offline renderer. You get renders similar to this, and then you post-process the image afterwards to your liking. But now you have a good base to work off of. Now I will show you how to set up some night scenes so that I show how to use the light tools, light blueprints. Okay, so I will delete everything. Actually, I won't delete everything. I will just change my sky. So I'll put this to 16, so I have some eye adaptation. So I'll take my sky blueprint, and now let's change this to night scene. So I will go into textures, and I will bring in some night HDR. I will use this moonlit golf scene. Bring it in. Now this looks like a day because it's overly exposed. So now when you're changing things, like when you have already set up the blueprints and you want to change the scene, then you go in and you plug in 1 and 1 into sky candela per meter square and base sky luminance to 1. we capture and update, and also make sure to disable the bloom. And as I said before, if you have some exponential height fog or atmospheric fog, disable those as well. Now we will take our light meter, point it at the sky, actually this is good, and find the middle value. (16) it's green. Calculate the average linear value, copy, paste it into the base sky luminance candela per meter squared, update. We could set our sun now to where the moon is, but we won't do that because I like how the sun is falling inside the room. So now we can check, okay, what's our typical night luminance values. So night sky is 1 millicandela per meter square. And night with moon is 1.34 millicandelas per meter square. So I will put this one in. So that's 0.00134 and update. So that's a pretty low value. And for our sun, it says full moon and clear night is 0.3 to 1 lux. So I will put in 1 lux and update. Now before we move on further, this is using the old light maps from the daylight scene, that's why it's all so bright. So before we move forward, I will put on some lights. So I will use some spotlights. I'll set them up here. And I will check what the typical light bulb settings are. So I don't want to use too high light bulbs with too high wattage. So I will use this lower watts, maybe 40. So that's 300 to 500 lumens. So here in my light settings, I pick lumens and I put them to, let's say, 400. Okay, now a couple of things about the light's blueprints. When you use candelas, if you're in the candelas units and you change, so let's just put this to like some very big number so that we can see the spotlight, since the light cache is overwriting our spotlight because it's too bright. So if you put them in candelas and you change the angle of the light source, so the cone angle, the intensity doesn't change. But I've put that if you use lumens and you change the outer cone angle, the intensity of the light will actually increase as the light cone decreases. And as the light cone angle increases, the intensity of the light will decrease. Same goes if you use luminance. Now, if we use luminance, the light intensity also takes into account the size of the light source. So if I set my radius to smaller, then the light intensity will decrease. If I set my radius to bigger, light intensity increases. That's because it's emitting the same amount of candelas but over a bigger surface. So I will use lumens as my values, and I will plug in 400 as before, and I will put my temperature to 3200. Now you can always change your spotlight's mobility when you go into the spotlight component, and I will change it to stationary so that the light mass calculations take it into account. I will now copy this light 3 times, and that's it. And I will also set up the TV so that I can show you how the rectangular light works. So I will put in a rectangular light, and I will set it to be the size of the TV, and I will increase its angle, and I will put it to luminance. So I know that a typical LCD TV or LCD screen emits between 150 to 250 candles per meter square. So I will put this to 200. I'll keep the temperature at 6500, and that's it. So just make sure that you know that the barn door angle also affects the intensity of the light. So that's it. Now we will set up our emissives on our models. So I will go into the material instance of this model's material. And it's important that you set up realistic emissive amounts. So we can put this value to something high, and I found that 2000 works good. Save. So that's pretty much it. Let's build our scene and see how it looks like. Now this is how it looks like immediately after build, and that's because I haven't set my exposure settings. Since this is a night time, the exposures need to be pretty low. So I will put in, let's try 8 first. So 8 is kind of okay, but we can go a little bit further down. 4 is too much. 5 or 6 is good. We can turn on some bloom. Okay, so we have kind of overdone our ceiling lights. That's because this is set to brightness of 1 to 2000. So I've just changed it to 1. And this is it. Now if we check our gamma, you see that our room is pretty dark, but with the gamma correction it works well. Okay, we can move on to some outdoor scenes, and then I'll go on to show you some other examples I did. Okay, so I've opened the Agora scene. I've deleted every light in the scene so that we can start from scratch, as you can see. Now the only thing I've modified in the scene is I've put every foliage to movable, because I'm using the GPU light mass, and my GPU light mass simply couldn't handle all this foliage and my GPU would crash. So yeah, that's why I've set everything that's foliage to movable. I realized that this is movable and it should be static. And I'll just change that, and I'll change this one to static. Okay. Now, the workflow is the same. We will be creating a sunset scene. So I go into my Tarkos Physical Light Blueprints, Sky. I bring out the outdoor lighting captured scene. And I will load in a sunset texture. This is the Skies on Fire texture. So we have this. And I will measure my sky, so I will bring in a light meter. Point it towards the sky, somewhere where it's not too bright nor too dark. And find the middle value. Calculate the average linear value and copy this and paste it into my blueprint. Update. And now I will see, okay, so for the sunrise sunset is 25 candelas per meter square for the sky, so I put 25 here. And for my sun, I will bring in a directional light. Check use temperature, and I will put my shadow cascades, 5000. Pick my sun. Update. And now I will just adjust quickly the EV so that I can see something. And I will lower my sun so that it's somewhere around the horizon. Like so. Now I know that for a sunset, the typical sun temperature is around 2000 kelvins, so 2500 works good for this. And also I will check my sun illuminance at sunrise sunset, 300 to 500 lux. I will put in 500 lux. So that's it. Now I need to build my sky, my lighting. So I'll come back when it's done. Okay, so this is the build, lighting build. And as you can see, here this is illustrated pretty well. We have a problem with specularity, so that's fixed by going into my blueprint and setting this parameter to 1. And also we have a problem with pretty dark shadows, so that's fixed with gamma correction. And this is our scene. Maybe we could slightly decrease the sun temperature to 200. Like so. And this is the final result. As you can see, the movable objects also fit in pretty well with the static ones, lighting wise. So it's important when you work on your scenes that you set up your materials in a realistic way. So don't overexpose your albedos or use any trickery to set up your materials to look brighter, because then when you use the physically based lighting, everything will be just too bright. So yeah. I have also downloaded the Sparrow character just to see how a character looks like when I put it into the scene. So if you have properly built volumetric light maps, then the characters should fit in and blend in with the environment pretty well. On this character, the only thing I needed to change was the eyeshadow opacity amount because it was too dark, but otherwise nothing else has been modified. So yeah, that's pretty much it. I will show you a daytime scene of this. So it's here. So I've built this before using the same tools, the same workflow. And this is how it looks like when it's daytime. So you can try, mess around, make a nighttime scene on your own, or just play around with the settings and with the sky domes and see what you can achieve with this workflow. Also, you can always try to add some post-processing. So if I add a post-process volume, I can change the contrast now, make it a little bit more, so it pops out a little bit more. I can correct the highlights so that they don't blow out that much. You can add your typical post-process settings. So where is it? Yeah. You can change the white balance, make it cooler, warmer. I like the warm look. So I'll show you some other examples I did. So here I have relit this sci-fi hallway scene. So this is all physically based lighting. As you can see, I didn't have to use too many lights. I just put the lights where the light sources are. I realized that if I set realistic emissive settings on the emissive materials and set them to actually emit light in the static, use emissive for static lighting, that my scene was already pretty well lit up. So all I needed to do was add some spotlights and some, final tweaking to the lighting so that everything looked how I wanted it to look. So I used the same setting as I did on the TV in the interior room. I set rectangular lights for the monitors. I set realistic settings on the monitors, so 250 candles per meter square. So this also has the outdoor lighting captured, but I just didn't use any sky because this is a completely interior scene. So I will show you another example. So I relit the sci-fi bunk scene. Again, everything is using physically correct lighting. Some use emissive materials. I realized that if I used emissive materials on small light sources, that GPU light mask can create those firefly effects. So you shouldn't use emissive and static lighting on emissive lights if you're using GPU light mask. As you can see, the character also fits in nicely with the scene. Everything is lit up well. Also, you can use, so you make a glass material on your windows, and then you can use the opacity to actually control how bright the outside looks like. That's basically what filmmakers are using when they're shooting indoor scenes and they want their windows to be visible in the shot. Then they use ND filters to actually darken the windows and not have the windows blow out. Okay, so this is this scene. I will show you another one. So I've relit the sequencer demo scene. The only thing I had to do here was to enable, so in the project settings, the exposure settings, and also I had to enable the ACES tone mapper because they used the old tone mapper by default. So you can see everything is nicely lit. I realized that there was already a lot of lighting without any of these artificial lights, because as the skylight was coming from here and as the sun was shining from here, it already lit up the whole environment pretty well. So we can watch.
You want to play? Okay.
Yeah, so I had to change some intensity values on the material instances. This could use some more contrast. The original was well contrasted. One of the reasons was because they didn't use the gamma correction in the tone mapper, and but yeah, so you could make this scene look much darker if you want, only through post-processing. So if you come into contrast, you can add the contrast back. You can take the white balance to a cooler tone. Or even tint it a little bit towards greenish. So yeah, you can control your images like this much more easily than, you know, being at the mercy of Unreal Engine's tone mapper without any gamma correction. So I have also made some renders of the different scenes in different times. So this is, you saw this as the daytime. I also made an overcast scene of the Agora, and this is the sunset. So this is the interior scene as the daylight. This is the nighttime. We did that. And this is just purely overcast sky, so no direct lighting in the scene. So this has only the skylight outside and nothing else. As you can see, even in the corner, there's visibility and light coming all the way through the room. So this is the sci-fi monk scene I showed you, and I also did a nighttime version. So here I have low exposure values, very low values for these red lights, and this is like a moonlit scene. And this is just using the sun, so nothing else. As you can see, the bounce light lights up the rest of the room pretty well. The train scene, so this is daytime. This is a sunset scene. Night scene without, and so with artificial lights and with the middle lights turned on. And also this is an overcast scene, so nothing else is lighting up the scene but the skylight. And it's all coming through these small windows, and it's still lit up pretty well. So that's it. Thank you for watching. I hope that this was useful to you, and I will be linking the tools in the description. Make sure to subscribe to me if you like the content I have. I will be updating everything. So as I go along and I discover new stuff about Unreal Engine, if I update the physically based lighting tools, I will make new tutorials and keep you posted. Thanks. See ya.